Hello and welcome to the WISE video on understanding bivariate relationships. While univariate information, for instance, average happiness scores or average diabetes rates in the US, are useful information, the pattern of two or more variables can provide much richer understanding of the data. Is there a relationship between exercise and health outcomes? Is there a relationship between happiness scores and the number of children that people have? In this tutorial, we will explore how to graph and describe the relationship between two variables. Let's assume that researchers are interested in assessing if there is a relationship between the number of children someone has and their self-reported happiness scores. Researchers randomly selected a group of parents who participated in their local parent-teacher association, or PTA, reported happiness score on a scale from 1 to 10. Here's a table of the data. And this contains 3 pieces of information for each participant. First, their name, the number of children they have, and their happiness score. Note that Alice has 5 children and a happiness score of 2. While this table contains all the information we need to assess if there is a relationship between happiness and number of children, this relationship is not readily apparent. A better solution is to graph each data point. Let's start with the univariate distributions, where only one variable is considered at a time. Let's begin with the data for the number of children each participant has. You can imagine the scenario where each participant is represented by a single block. In this case, the letter inside each box represents the first letter of a participant's name. This will allow us to reference each participant later in the video. On the horizontal or x-axis is the number of children a given participant has. Now imagine stacking the blocks. Alice has 5 children, so her box is placed over the number 5 on the horizontal or x-axis. The y-axis, or vertical axis, represents the number of participants with a given number of children. The boxes will stack on top of one another to indicate that multiple participants have a given number of children. Now let's consider how many participants had 3 children. Find the appropriate number on the horizontal axis and count the boxes. In this case, 2 participants, Bob and Carl, had 3 children. This distribution, called the frequency distribution, has several advantages over a table. First, the shape of the distribution becomes much more apparent in the frequency distribution than in the table. You can see that the bulk of the scores fall between 3 and 6, and only one participant has more than 7 children. The average number of children is probably somewhere around 5, and the distribution has a large bump in the middle and flattens out towards the more extremes, very few or very many children. All this information is conveyed simply with the frequency distribution, and this information would have been much more difficult to gain from a table alone. It is worth noting that in practical applications, each participant is not represented by a specific box. In the media and in publications, often the top of the bar is used to denote the frequency. To figure out how many adults had 3 children, we could go to the very top of the bar, see where that intersects with the y-axis, and that would give us the frequency of children for a given group. The same distribution can be created for the happiness scores. Once again, each participant's happiness score is represented by a box, and those boxes will slide over and stack to create the frequency distribution. The happiness score distribution is quite a bit different than the children distribution, with the bulk of the scores falling between 2 and 4, and the average probably being somewhere between 3 and 4. Now that we have a better understanding of the data through the univariate distributions, we may be interested in assessing if there is a relationship between the number of children participants had and their happiness scores. If we rearrange the data so the number of children variable is sorted from highest to lowest, we can see that the participants with fewer children tend to have lower happiness scores and vice versa. However, this relationship is not necessarily clear from the table alone. A better solution is to combine both of the univariate distributions and create a plot that connects every participant's happiness score to the number of children that they have. To create this graph, you can imagine the x-axis representing participants' happiness scores. We can then rotate the graph of participants' children to the y-axis. While the graph is rotated, the relationship between these values does not change. For instance, two people still have a happiness score of 4, and one person has a happiness score of 6. We now have a two-dimensional area from which we can graph a single point that represents the number of children a parent has as well as their happiness score. Let's start by plotting the point that corresponds to the number of children Joe has as well as his happiness score. To visualize this, you can imagine a vertical line stemming from his happiness score of 6 and a horizontal line stemming from 9, which represents the number of children that Joe has. The point at which these two pieces of information bisect is where the point is plotted. Now we can plot the point for the other parents in the sample. As a whole, we can estimate the direction and the strength of the relationship between happiness scores and number of children. In this example, there is an upward trend, such that greater numbers of children are associated with higher happiness scores, and having fewer children is associated with lower happiness scores. While this is not a perfect relationship, there is a clear positive trend in the data. We can now fade away the marginal distribution because the bivariate plot itself contains all of the necessary information. One important thing to note is that the univariate information is still preserved in the bivariate plot, even though bivariate plots do not contain the marginal distributions. By looking at any location on the x or y axis, we can extend a box to see how many parents had a given number of children or a particular happiness score. For instance, we can still see that 3 people had 5 children and that 2 parents had a happiness score of 4. Let's assume the researchers took a sample from a different group of PTA members in a different county and found a different relationship between the number of children one has and happiness. In this next example, there is a negative relationship between the number of children someone has and happiness scores. In this case, lower levels of happiness are associated with a greater number of children, and parents with fewer children will have higher happiness scores in general. This relationship is called the negative trend. As a final example, let's look at an example where there is no meaningful relationship between happiness scores and number of children. In this case, parents with many children are just as likely to be happy or unhappy as parents with few children. You can see here that this relationship is neither positive or negative, but flat. Now that we have explored univariate and bivariate distributions, let's recap what we've learned. While tables of data can be useful, graphing the data in either univariate or bivariate distributions gives a much richer picture of the data. Concerning univariate distributions, we get a picture of not only the shape, but the center and spread of the distribution. Concerning bivariate distributions, we can graph the strength and direction of a relationship between two variables and get an indication of the extent to which two variables are associated, whether it be a positive or a negative trend. Thanks for listening.